Okay, so let's try to compute the character table for S3. I want to determine all its irreducible characters, and therefore implicitly all its irreducible representations. Now, S3 is non-abelian. It has 3 different conjugacy classes, so we're going to expect up to 3 irreducible representations. When I care about the class functions, which only depend on their value on one choice of element from the conjugacy class. So I'm going to use these elements as my standard representatives of the conjugacy classes. Now, the first kind of representation I want to look at are the ones that factor through abelian groups, the one-dimensional ones. So let's first notice that if we take the commutator quotient of S3, you can compute the commutators in S3. You'll pretty soon see you can only get 3 cycles. So this quotient will be the quotient by the subgroup generated by a 3 cycle. So that's a group of order 2. That's going to have 2 distinct irreducible one-dimensional representations. And I'll just identify them by their characters. So I'll call them chi1 and chi2. Chi1 is the trivial representation, so its character always has value 1. Chi2 is the sign representation. It has value -1 on odd permutations and 1 on even permutations. When I draw these tables, I'm going to put the size of the conjugacy class up above the representative, because that helps when you want to compute the inner product. The inner product is going to be 1 over 6 times 6 terms, but I don't have to compute 6 numbers because 3 of them will all be the same. They'll all be involving elements in this conjugacy class, and 2 will be involving elements in this conjugacy class. So just to verify, chi1, chi2 works out to this. The 3 and the 2 are the sizes of those conjugacy classes. Of course, that does add up to 0. So how do we complete this table? Well, one way is to just have another representation. We know one. That's the standard representation. I've written down the matrices for those many times, so we can write down its character very easily. Here's the representation on those 3 elements. Here's the character of the standard representation put at the bottom of the chart with the 2 irreducible characters I found. Now, it turns out the standard representation is not irreducible. To see that, we can compute the pairing of its character with itself, which is that, which works out to 12 divided by 6, or 2. So rho is not irreducible. We knew that already. Let's compute the pairings with chi1 and chi2. That gives us this. Now we can work it out. This one's 1, this one's 0. So there's going to be a copy of chi1 in rho. So rho has to be equivalent to a direct sum of the one-dimensional representation chi sub 1, the trivial representation, and something else. What's the something else? Well, we know that when we add representations, we add their characters. And since I know the characters of rho and chi1, I therefore know the character of psi, whatever that other summand is. So now I can put in psi. I'll just subtract chi1 from the values I had for rho. That's going to give me 2, 0, and -1. Now, you can go and do the exercise. If I take this thing and pair it with itself, that's actually going to be 1. So this is also an irreducible character. Maybe I'll call it chi sub 3. It corresponds to a 2-dimensional representation. And we actually saw that before when I worked out explicitly the sub-representations of this one. By the way, there's another thing to note here. Remember, if I have a one-dimensional character, I can multiply it by any representation, I get a new one. So there's also a representation. Well, it'll be interesting when we take the character chi2 and multiply it by the representation psi. This in turn gets a character of its own, which is just the product of the character chi2 with the character of psi. That's also got to be a character of a representation. In fact, an irreducible one, since psi is irreducible. You can see, in fact, if you multiply them, you just get chi3 back, because that's the only irreducible representation of that dimension. In fact, you could have used that fact to predict that this entry had to be 0. Since if this is an irreducible character, so is this one, and there's only one possibility left, the value on an odd permutation would have had to be 0.